Hi class, how are you today? Wow, that's real. The learning target for today is to be able to categorize and order real numbers. For the scale, you're a 3 if you can categorize and order real numbers. You're a 2 if you can categorize or order real numbers. You can do one or the other. You're a 1 if you can order most real numbers, like there's some you can't get, which is fine. Like irrational numbers are usually pretty hard. Some weird fractions can be difficult. And 0 if you cannot order most real numbers. All right, let's get started. Now we're going to look at the real numbers. Now, all numbers that you have ever dealt with up until now are real numbers. And we're going to look more specific at them. And the very smallest set that we like to deal with are called the natural numbers. And as a smaller, shorter way to write it, we like to just call it n. And there's a fancy way to write it, but if you just say n, I'll know you're talking about the natural numbers. The natural numbers are also sometimes known as counting numbers. So 1, 2, 3, 4, 5, and then as far big as you can go. So examples of natural numbers are 4, 87, 942, so on. Those are natural numbers. Next, we have whole numbers. Now, whole numbers are very close to natural numbers, and sometimes mathematicians only look at natural or they only look at whole. And the only difference between whole and natural is that whole has the number 0 in it. 0 is a whole number, but it is not a natural number. And then all natural numbers are also whole numbers. Then we get a bit bigger and we get integers. By the way, I did forget to say whole is usually denoted with a W, and integers are usually noted with a Z. And integers are positive and negative numbers. So all the natural numbers, 0, so all the whole numbers, plus any negatives. -2, -107, -1112, whatever, negative numbers. So integers include positive and negative numbers and 0. Then we get to what are known as the rational numbers. And rational numbers are usually denoted with a Q. I don't really know why, maybe like quotient, because it deals with dividing and fractions, but it's Q. And like I just said, rational numbers are any numbers that can be written as a fraction. So whether you're talking about actual fractions, like 3/4, whether you're talking about decimals, 1.7, repeating decimals, like 1/3 is equal to 0.3 repeating, that's a rational number. Both of them, 1/3 and 0.3 repeating, are rational numbers. Essentially, if you can write it as a fraction, it's rational. If you're looking at it as a decimal, it either ends or it repeats. Those are rational numbers. And then over off to the side here, we have irrational numbers. These very easily are denoted with an I. These are numbers that, when written as a decimal, they never end, but they never repeat. A very famous one is pi. You know it as 3.14, but it actually goes on forever, but it doesn't repeat. Another one, square root of 2. Any square roots of whole numbers that don't give you a whole number back, those are irrational. So square root of 2 is another one. And there are a whole bunch like that. And then real numbers. Real numbers are denoted with an R. Real numbers are rational and irrational numbers combined. So rational numbers include integers, whole numbers, and natural numbers, but real numbers include rational and irrational numbers. So all of these numbers here are real numbers. All right, now let's use what we just learned. So name the sets of real numbers to which each number belongs. So square root of 11. You can't take the square root of 11 and get a whole number out of it. So automatically, we know that this is irrational. And if you just want to put the I, that's fine. I know what you're talking about. And if it's irrational, that means it's also real. So we got the I and we got the R. You can either write that they're irrational and real, or you can just put I and R. I don't know what you're talking about. Then we have negative 8.13. Well, it's negative, so it's definitely not a natural or a whole number. You would think maybe integer because it's negative, but it's a decimal. Integers are only negative and positive whole numbers. So that means since it's a decimal, it must be rational. It doesn't end, it ends, and since it ends, we know it's not irrational, but it's a decimal, so it's rational. Essentially, any decimal that ends is always going to be rational. Remember, this is a Q. And if it's rational, it must also be real. Just to note, all of these are real numbers. 21/7. First thought, oh, it's a fraction. It must be rational. And yes, it is absolutely rational. However, 21/7 is not fully reduced. 21/7 is actually 3. 21 divided by 7 is 3. So that's what we got to look at. We got to look at 3. Well, 1, 2, 3. It's a counting number. It's a natural number. Natural number n. Okay? Well, if it's natural, it's also whole, W. It's also an integer, Z. And it's also rational, Q. And it's also real, R. Again, you don't have to write all these out. You can just write N, W, Z, Q, R. But some people would prefer to actually see the words. So for this one, it's actually all of these. It's not irrational though, because those are only ones that are decimals that go on forever but never repeat. So it's all the other ones. And you do have to put every single one of them, not just one that it fits in, it's all of them. All right, now we're going to order these numbers. We want to write these numbers in increasing order. So we're not really worried about what type of number they are. We're worrying about the order that they go in. So increasing order means you start at the lowest one and go up. So if we start at the lowest, we got to start in the negatives, right? So we've got two negative numbers here, -5/2 and negative square root of 3. So we don't have to give the exact values of these, but try to find about where it is. So -5/2 is pretty easy to figure out. 5 goes into 2 2 times with 1 left over. So we know this as -2.5. You can also write it as -2.5. Okay? Well, let's see if negative square root of 3 is lower than that. So the way I like to do square roots to figure out about where it is think of perfect squares that are bigger and smaller than it. So for example, 2 times 2 is 4. So that means square root of 3 is smaller than 2 because the square root of 4 is 2. But then 1 times 1 is 1. So the square root of 3 is bigger than 1. So it's between 2 and 1. It's somewhere between 2 and 1. So that means it's 1 point something, right? And that's all we need to know because it's negative. So that means negative 5 over 2 will come first, and then negative square root of 3. Then we get into positive numbers. Again, we got to look at a square root. Square root of 2, again, square root of 4 is bigger. So 2 is bigger than it. 1 is less than it. Square, because 1 times 1 is 2. Because 1 times 1 is 1. So that means 2 is bigger than it, but 1 is less than it. So it's between 1 and 2 again. So again, 1 point something. So we got 1 point something, we've got 3, and we've got 1. Well, of those 3 numbers, we know 1 would be the smallest. 1 point something would be next, so square root of 2. And then 3. And these are now in increasing order. Now time for the sponge activity. For the sponge today, we've got 2 different types of questions. First, name the sets of numbers to which each number belongs. So write all the sets, not just one of them, but all of the ones that they belong in. And then number 3, write the numbers in increasing order. So start with the smallest and then go up, just like we did in the last example. All right, that's it for the lesson. Please make sure you took notes on the entire lesson. If you didn't, go back and do it. Take a picture of all of it, notes and sponge. Submit it all to Google Classroom, and have a good night.